Hello everyone, you're watching another episode of Military TV. In today's session, we're going to discuss how underwater explosions damage the surface ships and submarines. If you're curious on what typical damage it might cause, don't go anywhere, just stay tuned only on this channel. Explosive detonations which occur underwater create shock waves in a similar manner to explosions in air. Due to the elastic properties of water, the shockwave tends to be of shorter duration, but with a proportionately larger peak overpressure. The energy in the underwater shockwave slows very quickly with range. Therefore, the shockwave from an underwater explosion doesn't cause the same level of damage as one would expect from studying explosions in the air. However, this isn't to say that there's no effects from underwater shockwaves. The effects of an underwater explosion can be divided into two distinct phenomena: the shockwave and bubble pulsation. So what are the differences between an underwater explosion and a blast in the air? First, while overpressure increases quickly at the shock front in air and water, it lowers swiftly in an air explosion. As a result, peak values in water are substantially greater than peak values at the same distance from an equal explosion in the air. Second, in the next stand, the sound velocity in water is roughly 5 times that of air. As a result, it creates rapid waves in the water. One of the most dangerous short-distance explosions, around 2 to 20 meters, is the explosion of bottom mines in shallow water. The pressure wave created by the button accelerates ship destruction significantly. Moreover, the bubble's pulsation generates additional shock waves. Underwater warheads use the interaction of the steam void created by the explosion with the target's hull to be the most effective. It's important to note that if a warhead detonates beneath the ship, underwater explosions are more devastating, and there's a good reason for it. The bubble either elevates the keel or removes water from the area. Because there's no water in this area, it has less buoyancy, but the bow and stern are still supported. Aside from the shock wave, the stress in the midsection is caused by the ship falling into what's essentially a hole in the water, while the bow and stern are still supported by the water. Another question is why bubble actions seem to be more dangerous for submarines. Under certain circumstances, the bubble's migration due to hydrodynamic and gravitational impact might result in a highly concentrated transfer of momentum to ships or other structures, such that the bubble action can outweigh the shockwave's damaging effect. The expanding and contracting steam bubble that'll cause cyclic stress on the hull could damage submarines, which would be quite unpleasant a few hundred meters below the surface. Lastly, an underwater explosion can create a positing bubble, which can cause continual stress on a target and may inflict long-term damage even if the initial shockwave is avoided. As a result, targets are ideally attacked with beneath-the-keel explosions, which allow the target's weight to be used against it by creating a void beneath it. The targets are crushed under their weight. Although this method does not work for submerged targets, an exploding bubble adheres to the hull when it comes into contact, and the cyclic stress from the expanding and contracting bubble can damage the hull. That's all for today. Thanks for watching. If you like this video, don't forget to like, comment, and share, and the most important one is to hit the subscribe button for more updates on awesome videos. We'll see you in the next one.